All right, on page 133, we are talking about savings accounts and we are talking about interest. There is a lot to read. I will read it. I do need you to try to follow along. Okay? All right, most savings accounts advertise an annual interest rate. Annual interest rate. What does that mean? Do any of you know? If it's done annually, it's done yearly. Once a year. But they actually compound that interest at regular intervals during the year. Maybe you didn't know that. That means that if you own an account, you'll be paid a portion of the interest before the year is up. And if you have that payment in the account, you will start earning interest on the interest you've already earned. Now, if any of you do have money in an account, which a couple of you said you do, if it gains any kind of interest, it is not much at all. Or at least mine isn't. It's paltry. Like maybe less than $2. It's terrible. Anyway, for example, suppose you put $500 in a savings account that advertises 5% annual interest. If that interest is paid once per year, then your balance B after T number of years could be computed using this equation. B equals 500 times 1.05 to the T power. Since you'll end each year with 100% plus 5% of the amount you began the year with, okay? So that is if they compound it yearly, if it's paid once per year, okay? On the other hand, if that same interest rate is compounded monthly, if it's compounded monthly, then you would compute your balance after T number of years using this equation. B equals 500 times quantity 1 plus 0.05 divided by 12 and quantity raised to the 12T power. Okay? So the differences are right here. If it's compounded monthly, you're going to take that percent and divide it by 12. And it's just the percentage, okay? Just your growth rate. Divide by 12 if it's compounded monthly. And in looking at the time over here, you're going to multiply T, which is your time in years, by 12. So those are the big differences between compounded annually, once a year, and compounded monthly. Okay? So letter A, why does it make sense that the equation includes the term 0.05 divided by 12? Why does that make sense? Or maybe it doesn't make sense. What is the 0.05 again? 0.05 is my rate, my growth rate. Why is it divided by 12? Right. So this growth rate, when compounded monthly, needs to be divided by 12. Because there are 12 months in a year. So you are still getting the same rate, but since they're compounding monthly, you're going to end up with a different amount. Right now, we don't know if it's going to be more or less than if we would compound it once at the end of the year. So that growth rate, when compounded monthly, needs to be divided by 12 because there are 12 months in the year. And we're taking that rate throughout the whole year. Okay? Any questions on that? Okay. Second slide says, how does this equation, the one that we're talking about right here, reflect the fact, bless you, that you opened the account with $500? How does that equation reflect the fact that you opened the account with $500? What tells you that? Yeah, it's in the initial amount part of the equation. So $500 is in the initial amount part of our equation. And what else? If I am just opening the account, what would my T time be? 0. Yes. And T would be equal to 0, which in this case, 12 times 0 is 0. 1 plus whatever that is raised to the 0 power gives us what? Anything to the 0 power is... No, not 0. 1. And so 500 times 1 gives you that same amount back, 500. So 500 is the initial amount part of the equation. And if T is equal to 0, I'm going to say, comma, the growth factor would be 1. Growth factor is 1 and gives us the $500 again. So that tells us that $500 is the initial amount because T would be 0. Anything to the 0 power is 1. Does everybody understand that? All right. Then it says, what do the numbers 1 and 0.05 divided by 12 represent in this expression? Well, let's talk about 1 first. What does 1 represent? A little bit louder. It's part of the growth factor. This whole thing is actually the growth factor because it's 1 plus the rate, right? So this whole thing is the growth factor. But specifically, what does that 1 represent? Say it louder. You guys are, you belt it out, man. It actually, we don't know. It depends on what this is, whether it's being added to or subtracted from. So I understand what you're saying, but we're not quite there. What were you going to say, Kelvin? Oh, you might be right. You don't want to say it?
I was going to say if it represented growth or decay.
Okay.
It was going to make sense.
Okay. The 1 itself represents 100% of your initial money. Okay? So that's the money that we are earning the interest on. That's the 1 part of it. So if we just said 0.05, that would be the 5% of the money putting in. But when we say 1.05, that is the whole amount plus the interest that you're going to get. Okay? So 1 represents 100% of your initial money. So then the 0.05 out of 12 represents the 5% interest being compounded monthly on the initial amount. Does that make sense? But it's compounded monthly. So we're recalculating it after every month. So we can earn interest on the interest if you leave that interest in that account. Any questions on what I'm saying there? Okay. And finally, what does the 12T in the equation represent? What does the 12T in the equation represent? Well, let me back up. Let me ask this question. What does the T represent usually? Time in what? Time in what? No. Usually it's years. Not always. But usually it is what we calculate for in terms of years. So if T represents the time in years, that means 12T is going to represent what? Time in months. Yeah. In months for T number of years. So if T is 3, then 3 times 12 would be 36 months. 12T represents time in months for T number of years. So if you're compounding monthly, you want to be using to the 12T power. Okay? Any questions on this? Like I said, the important parts are if you're compounding monthly, you need to divide the interest rate only by 12. Okay, whether it's 5%, that would be 0.05 divided by 12. If it's 7%, it'd be 0.07 divided by 12. And then the other important part is if you are compounding monthly, you want to raise it to the 12T power. Okay? All right. Now, let's turn to page 131. We're going to flip back now. Task number 11. I really felt like this first part of this slide did a good job with that. Now we're going to go back to 131. And we're talking about banking. Okay. Here we go. So on page 131, when you invest money in a bank account, the same terminology and notation applies. For example, parents of a newborn baby want to invest money today in order to pay for college 18 years from now. They have $10,000 of savings to deposit. in a savings account. Bank A has an APR, which stands for an annual percentage rate, of 6% with monthly compounding. So that means at the end of every month, they are going to recalculate the interest on your money. Bank B has an EAR, which I've never heard of, but I'm not big in the banking, an effective annual rate. So it is compounded once annually at 6%. So if you notice, they're both at 6%, but Bank A is going to compound it monthly, and Bank B is going to compound it once at the end of the year. So the question is, which bank has a better savings account? Which bank do you think is going to get you the more money? Well, let's see. Bank A and Bank B. I want everybody to vote. Bank A. Who thinks Bank A is going to make more money? You're all not voting. Or you all think Bank B. How many think Bank B is going to make more money? I had one person vote. You guys stink. Come on. Bank A, what do you think?
I think Bank A will make more, but Bank B will save.
Well, we're talking about for 18 years. They both have the same time because they're going to be going to college in 18 years. We're both starting at $10,000. They both have 6%. One has an annual percentage rate with monthly compounding. The other has a 6% rate with compounded once a year. All right, so I'm going to each person. Kelvin, what do you think? A or B? T, what do you think? B? What do you think, Anaya? What do you think, Lanaya? Jalen, what do you think? Of course, I should have written names because I don't remember who said what. What do you think, Adja? A. And Taylor? B. Wow, we're pretty split. All right, so let's figure it out. Here is my exponential equation. A equals P times 1 plus or minus R raised to the T power. For Bank A, over on the left-hand side of the column, in the red trunks, we have Bank A. So we don't know how much we're going to end with. How much are we putting in initially? No. What's it say? How much are we putting in initially? Huh? 10,000. Don't say 10,000. Say 10,000, Miss Dee Dee. Yes, $10,000. Guys are so quiet. All right, times. This is going to be 1. Is this going to be a growth factor and rate or decay factor and rate? Growth. 6%. How do I write 6%? 0.06. So 6%, move it 2 places to the left, is 0.06. So 1 plus 0.06 to the T power. How long are we going to keep this money in the bank? 18 years. So let's calculate. Let's see if we put $10,000 in, and this is compounded once a year for 18 years, how much money are we going to make? And that's another thing. It's like, how are you putting this in the calculator? All right, I got an answer. You? I'll tell you what I did. I do the exponent first and then multiply by 10,000. But these calculators are pretty nice. They usually do it the way you want. Who's got an answer for me? Be bold. Come on. $28,543, and don't forget that 39 cents, man. All right, that's what we get for Bank A. $28,543.39. What do you think about that? Does that sound good if you just leave it in there and let it work? Don't add anything to it? It's not bad. More than doubled, right? All right, let's figure out for Bank B. Bank B. So we start off the same. A equals, do we have the same amount initially? Yes, we do. $10,000 times 1. It is increasing, so that's a growth. Now, this is where it goes different. How would I represent this growth rate? What percent is it again? 6%, which is still 2 places to the left. So that's 0.06, but it's being compounded monthly. So we're going to spread it out over the 12 months of the year. Okay? And because it is being compounded monthly, I need to calculate it times or raise to the 12 times 18. 12 times 18. Because it's 18 years, but we need to figure out times the 12 months. So A equals, all right, let's calculate this. And again, knowing how to calculate this correctly is probably the trickiest part. Oh, I should have put that in parentheses. If I do that, that's going to make me do it all over again. Oh, that's not right. Oh, dang it, I did it wrong. 1 plus 0.06 divided by 12. There. Raised to the 12 times 18. Okay. All right, did you get an answer? Anyone? Anyone? $29,367.66. So, which is the better bank? Which is going to get you more money? B. B bank is going to get you more money. And it says by how much in this specific situation? How would I figure out by how much? Subtract. So take that. 29,367 0.66 minus 28. 543.39. What do we get? $824.27. Any questions about how we came up with that? T, you okay? You look like you're looking intently. Any questions at all? All right, we got one more question to answer. So Bank B has the better, gets us more money. And let's look at the last one. It says, for whichever account you choose, the one that compounds the interest monthly or the one that compounds the interest yearly, if those parents wish to have $150,000 in the bank account in 18 years, how much do they need to invest when the baby is born? So guess what? We're going to use that same formula, right? A equals P times 1 plus or minus R to the T power. Do we know what my A value is? What is it? What is it? No? A, we'll get to that in a minute, but either way, A would be the same, which is what? You were right. $150,000, right? That is the final amount we're going to say that we want to have. Equals P. Do we know what P needs to be? No, that's what we need to solve for. So P is going to stay as P. Do we want to choose this as the yearly compounding or the monthly? Which would be easier to figure out probably? The yearly, right? So let's do the yearly. So that's 1.06 because they were both 6%, right? And to the T power, how long were we putting this in the bank? 18 years. So I'm trying to solve for P. I want to get P by itself, right? So what would I need to do? I need to divide. Now, you can either calculate this and see what it is and divide, or you can divide it on the other side. So $150,000 divided by 1.06 to the 18th power. These cancel out. So P, the initial amount we would need to put in, would be what are we getting? Who's got an answer? That is correct. $52,551.57. Yeah, because if you invest $10,000 with 6% interest in 18 years, that only got us like $29,000. That's probably not enough for a lot of four-year colleges. If you want to have $150,000, you got to put in $52,500. Now, I think $150,000 is a lot, probably more than most. Yes, question.
Why did we drop the plus sign?
Why did we what? Oh, the 1 plus R. I just added because our rate was 0.06.
Oh, you just added.
I just added it as 1.06. Good question though. If you're not sure, that's why you ask. Okay? Any questions about this? Any questions at all? So according to this, Bank B compounding how? Annually was better. That seems odd. Let me look in my cheat sheet book. Make sure we didn't make a mistake. Let's see. I got I know. I see what I did. I was like, I'm almost positive that Bank A won in the other one, but you guys didn't tell me. I did Bank A as the one doing it yearly, didn't I? Do you see that? So I switched them, but since everything was the same, as long as I was consistent, so Bank A, we did yearly compounding. Okay, that makes sense. And Bank B, we did the monthly compounding. So let me reiterate, monthly compounding wins. Okay? I switched it. Do you see that? Accidentally. So this one was compounded monthly and it ended up with more, which makes sense because you are earning interest on more money. You see that, Kelvin? Yeah, because Bank A should have been the one that was doing it monthly. But since they're both the same amount, this one we ended up calculating yearly and this one monthly, and monthly wins. Okay? So if you go into a bank, most likely if they compound the interest, if they calculate the interest more often, that's going to get you more money. Okay? Tell them to show you the numbers, show you the money. And it also might depend on how long you keep the money in there, too. Sometimes they'll say you have to leave it in there for a minimum of 5 years or something. Any questions about this? I think it's kind of interesting. All right, so good job today. We're done with the notes. Now, I think we can do homework 7.4 on Canvas. 7.4 on Canvas. Tomorrow we will do some more with money. And on Friday, I'm going to give you the packet of the project so you can start to look at that over the weekend. I have asked for Monday off, so I will not be here on Monday, but you should be able to get started in the packet. And if you have any questions on the packet on Friday, you can ask me then, okay? And we will work on the packet. That'll be your final chapter test grade, is that project. And we'll work on that all of next week. And then we'll start getting ready for finals, okay?